Hello to all the cloud enthusiasts. How are you all doing? I hope that you all are doing at the best of your health, at the best of your wealth, and I'm sure that you all are trying to be a better version than yourself by learning some kind of skill, by learning some kind of technology, so that your future self can thank you for what steps that you have taken today. My name is Tejas Mahendkar. As you all know me, you have been following me. I'm sure you have been following me. You have been looking at my content that is on my channel. And before we move ahead, I just want to give you a quick introduction about me. Hi guys, like I said, my name is Tejas Mahendkar. This is my LinkedIn username. If you search for Tejas Mahendkar on LinkedIn, you'll land on my profile. You can connect with me. I'll be very happy to connect with you. If you want to look at the content that I've been putting on YouTube, the Cloud Minds is the channel. I've been putting content about the AWS specifically, and I've been making it simpler for you to understand. Now on this channel, I've put content right from what AWS is, why there is so much of a buzz about the cloud technology, why the companies are moving towards cloud technology, and how you can become a cloud enthusiast and learn AWS. If you have been following me, you already know that I have been putting so much of content for you, and I've been giving content to you that is specifically related to the AWS. In case you have any doubts, you want to reach out to me, thecloudsimplifier@gmail.com. That's my email ID. You can always send me an email, and then if you're stuck somewhere, if you need any help, I'm always there to help you. Now guys, what about today's topic? It's an interesting topic today. Today we are going to discuss one of the top services for networking in AWS. Any guesses for that? If you have guessed VPC, you're partially right, because it's not only VPC that we are going to look at today. We're going to look at how to create VPC, how to create the subnets, and the most importantly, we are going to look at how to calculate the IP addresses or the CIDR block ranges. And when I for example, when I say 10.0.0.0/24, when I give the net mask of 24 or 28 or any other number, what does it mean? How many IP addresses can I get from it? We are going to look at specifically that calculation today. Guys, it's very simple calculation. I'm sure there are many applications, there are many online websites that will provide you these numbers quickly, but you know what, imagine that you are in a room full of your colleagues, your peers, your friends, and you're giving some presentation, and then your team lead or your project manager or your friends ask you, when I say /24, how many IP addresses will I get? Instead of being embarrassed at that particular time, it's always better to know the answer, and then you can also explain to them how you have arrived at this particular number, and that will be really impressive, guys. So I want you to learn that. That's the reason why I thought I'll make this specifically this video. And then once we are done with this video, you will definitely know it's a very simple calculation, of course, but then you will know how to derive at this calculation or at this number. Alright guys, let's start with the AWS Management Console. We know that when we land or when we create an AWS account, this is the landing page, or this is the AWS Management Console page that we land upon, and then we can search here for VPC, and we can go to the VPC dashboard. Alright, let's give it some time for it to load, and then we can go to the VPC console. Alright, like I said, let's type VPC here, and then we will go to the VPC Management Console or the VPC dashboard. And once we land on the dashboard, we can look at this page wherein it says how many VPCs we have, how many NAT gateways we have, how many subnets we have, etc. But if you see that whenever you have created an account, you're already provided with a default VPC. So once you look at the default VPC, once you click on this, you will be landing on, and the next page will show you what is the default VPC that has been shown here. Alright, so what we'll do is we'll go ahead and create a VPC, and for this I'll name this as my test VPC, and the CIDR, the classless interdomain routing, that is the full form of CIDR. The CIDR range that we are providing here would be 10.0.0.0, which is for private IP addresses, /24. Now guys, think about it. When I say /24, what does it mean and how many IP addresses would it have? Now there is a very simple calculation which I wanted to tell you about. Now, whenever we talk about IP addresses, it is a 32-bit numbering system. We all know that this IP addresses is 34-bit numbering system. It is running out of numbers. That is the reason why we have IPv4, IPv6. All right. So coming back, whenever we think about the IPv4, we know that it is a 32-bit numbering system, and the number 32 is a very important part in it. Okay. So whenever you have /24 net mask, you just have to subtract that number from 32. For example, if I say 24 and if I subtract that from 32, I get what? 8, right? 8 is the number that is remaining after I subtract 24 from the 32, which is the 32-bit numbering system. All right. So whatever is the number that is remaining, you have to power it to 2. All right. So for example, the number that was remaining right now was 8. You should always say 2 to the power 8, and the number that is derived after you do the 2 to the power, the number that is remaining will be the number of IP addresses that you will be getting. Alright. For example, here when I say 32 minus 24, Google will provide me 8, right? And when I say 2 to the power 8 is the number of IP addresses that I will be provided. Guys, one point to remember is whenever you take this 256 IP addresses, not all of them are allocated to you. There are 5 IP addresses that are restricted or that have been used by the AWS itself. So you cannot use the 5 IP addresses. For example, if you take this, in this case, 5 IP addresses are already allocated or reserved by the AWS. So you'll get only 251 IP addresses. All right. So let's go back and try and understand. So when I say 10.0.0.0/24, what I mean is I'm trying to allocate 256 IP addresses, which if you ask me is a less number, of course, but for the testing purpose, for the sample purpose here, for the tutorial purposes, I'm using /24. All right. So the name, it has already taken my test VPC as the name. I don't want to change anything else. I'll just create the VPC. Now once the VPC is created, what we need to do is we need to create the subnet. All right. Now to understand VPC, it might be really confusing for people who are really new. So I'll try to give a real world analogy of what VPC is. Supposing you are at your hometown and you have a lovely house in your hometown, and the house has fence, right? So the house is protected by the fence. The fence itself here in AWS, the fence itself is actually your VPC, which is protecting your services or your instances that you want to deploy within the VPCs. Subnets are again isolations within the VPC. For example, now the VPC that we have created has 256 IP addresses range. We can further isolate those 256 into 2 subnets, which is again small isolations within the VPC itself, and we can create 2 subnets. For example, one we can keep it as public subnet, and one we can create a private subnet. Now why do we need this distinction? Now for example, when we create a public subnet, we can put the instances within the public subnet. We can give it a range and then put the instances within the public subnet, and we can attach something called as an internet gate. Of course, if we go back to the analogy, your fence will have some kind of opening or some kind of a gate, correct? If the fence is, there has to be some kind of opening for you to get into your house. So that gate is the internet gateway. Anything outside of the internet gateway is actually the internet or the world. Anything within the fence, within the VPC, is your AWS backbone or your AWS services. All right. I hope that it is pretty simple to understand. Let's go ahead and create 2 subnets, one a public subnet and one a private subnet, and we'll give different CIDR blocks. And guys, remember that the CIDR blocks that you're giving in 2 different subnets cannot overlap. If they overlap, then obviously AWS will start complaining about it. All right. So to create a subnet, we'll have to first choose a VPC. Now it is giving us option of both the default VPC as well as the VPC that we had created. We'll take the VPC that we have created, and I'll name this as my public subnet. Why am I naming public subnet? Because as I said, we need to isolate it, And then we need to understand that whenever we create an instance, for example an EC2 instance on which we are going to deploy the web applications which will be accessed by the whole world, then we'll have to put that in a public subnet. There might be some services, for example RDS service, for example if you want to put the data warehousing solution, the Redshift there, you can just put it in a private subnet, and that will also have something called as a NAT gateway. It will not have an internet gateway, it will have something called as a NAT gateway, which will allow egress only, or it will only allow the traffic to go out from the instance as from the services to the internet, and then not the other way around. Nobody from the outside world or outside of that AWS backbone can access those particular services, guys. All right, let's come back, and then first we'll create my public subnet, and here is where we need to provide the IP addresses range. Now for example, if I say 24, it has given me 2 to the power 8. Now what if I want 2 to the power 4, 16, or let's bump it up a bit, let's say 2 to the power 6. I want 64 IP addresses in each, for example. Okay, so when I say 6, it means it is 10.0.0.0/26. Now why do I say 26? Because if you subtract 26 from 32, the number that we have already spoken about, then you get 6, and 2 to the power 6 is 64 IP addresses. Let's do 10.0.0.0/26, which will give us 64 IP addresses. That's what it is providing here as well. Alright, and the name, like we said, we have already given the name, and it has been added as a tag. Let me go ahead and create another subnet, that is the private subnet. Right, so this is the private subnet. I've given it the name as private subnet. Now whatever is the IP addresses, we cannot reuse these IP addresses, so I cannot use this same IP address. What I'll do is I'll just copy this, and then I'll change the number from 0 to 64. Now why I'm changing 0 to 64? Because when you say /26, it is allocating 64 IP addresses from 10.0.0.0.0 till 63, which means it is allocating 64 IP addresses. Now guys, the point that I said, we need to remember that the first 4 and the last IP address is always reserved by AWS, even within the subnet, so you cannot use it. That will be known after we have created the subnet. Alright, so let's see if it will allow us to create the subnet. Now when I hit the create subnet button, voila, that's the subnet that we have created. Private and public subnet we have created. If you scroll down, if you scroll a bit, you'll see that 64/64 is the private subnet and 000 is the public subnet. Alright, and if you see that it is put both of them in the same availability zones, I would highly recommend that just for the architectural purposes or the fault tolerance purposes, we'll have to put them in different subnets. Of course, they'll have to be in the same VPC within the same region, but the availability zones have to be different for it to be fault tolerant. Whatever services, for example, you put inside these, it is always best practice to have a fault tolerant architecture. So that is the reason why you'll have to put it in different availability zones. Now if you also see here the available IP addresses, it shows us as 59, and whereas we had seen it that there were 64 IP addresses. So as I said, the 5 IP addresses are already reserved by AWS. That's the reason why you will see 59 available IP addresses, right? So now coming back, like I said, we need to understand for the public subnet we need something called as an internet gateway. For private subnet we need something called as a NAT gateway, and we need route tables as well, so that the instances within the public and private subnet could find the route to the internet gateway, go out, come back, and then so that whatever the data that has coming back from the internet or somebody is trying to access from the internet, they can go directly to the public subnet and access it. That's the reason why we have to configure internet gateway as well as route tables. Well, the configuration of internet gateway and route table will be taking it up in the next series, in next episode. Here we are only concentrating more on creating a VPC, the subnet, and the calculation of the CIDR ranges and the available IP addresses. Alright, so if you see here, I have created an IP address range of 20/24, and then it has given me 2 subnets. I've also created 2 subnets. One is a private subnet and one is a public subnet, which is attached to my test VPC. Alright, now Why do we use this? If you go back to EC2, let this page load and then we'll come back and I'll show you. When I go back to the EC2 instance, let me just click it here so that it doesn't. Okay, now you see that the private and public subnets are there. When I click on EC2 instances and when I try to launch the instances, one of the things that we get asked is the network settings, and in that we are asked about the VPCs. When I say edit, it will give me the option to edit and enter the VPC. So this is the VPC that we had created, and this is the private and public subnets that we had created. So we can click on the public subnet because, for example, this instance that I'm creating, I want to host a web application on it and I want the world to access this. That is the reason why I'm keeping it in public subnet. Right? So once I configure this, I can say launch instance, and then this instance will be launched in the public subnet of the VPC that we had created. That is one of the use cases. Similarly, if we have to put any other services like the database services or any other services, we'll have to configure them and put them in private VPC. We can always go back and then we can always configure whether we want them in private subnet or the public subnet. But as I said, the use of public and private subnets are all different, guys. Alright, so if you want somebody to access your instances, you can put them in public subnet. If you don't want anyone to access your instances, you can put them in private subnet. That is how the isolations are, and that is how the CIDR block or the IP addresses calculations is. Alright guys, I'm really happy that you stayed till here, and then I hope that I was able to make justice or make you understand how do we calculate the IP address or the CIDR block, and then how do we when we take the instances, for example, how do we put it in the IP address or in this subnet range. All right, there is one of the important, very nice websites that I've seen, which is called the CIDR.xyz, wherein if you put 0.0.0.0 and if you put 24, for example, it will tell you how many counts of IP addresses that you'll get, what is the first usable IP and what is the last usable IP. This is one of the very nice websites that I had found, so I thought I'll share with you guys. Alright, so guys, like I said, thank you so much for being with me till the end, and if you have not subscribed to this channel, do consider subscribing to this channel, and if you have liked the video, do share it with your friends who are newbies, who are trying to learn the VPC or the cloud technology and they're finding it very difficult. The analogies that I've provided here will definitely help them. Alright guys, this is Tejas signing off, and it was really great to talk to you. Have a great day.